Good day everyone, we are Group 9 and today we will be presenting our project for Object-Oriented Programming Fundamentals. The title of our project is Library Management System, which is designed to manage library operation efficiently using object-oriented programming concept. Now, I would like to pass the time to my group members to introduce themselves and present the following parts of our project. My name is Soyu Pei. Now I will be presenting the system overview of our library management system. This system is designed to help manage daily library activities in an efficient and organized way. The overall control of the system is handled by the library system class, which is responsible for displaying menus, handling user interaction, and processing users' input through a console-based interface. Supporting this, we have the library class, which manages all the core data in the system, including books, members, librarians, and borrowing records. Whenever a book is borrowed or returned, the details are recorded using the borrow record class, which stores important information such as the borrow date, due date, return date, and any overdue fine. The system also supports different types of members such as standard member and student member. Each member type has different borrowing limits and fine calculation rules, allowing the system to be more flexible and realistic. In the terms of functionality, the system allows librarians to add, search, and remove books and members. It keeps track of borrowed books, monitors due date, detects overdue record, and automatically calculates overdue fines. The system also updates the availability status of books when they are borrowed or returned. Overall, this library management system helps streamline library operation and ensure accurate recording, keeping through a simple and user-friendly console interface. Thank you.
Hi, my name is Shihant. I will now begin to explain the object-oriented programming concepts used in this project. The first concept I would like to explain is encapsulation. We used private attributes in all our classes with controlled access through getters and setters. For example, in our library class, the setMembers method includes null checking to ensure system stability. Next, inheritance, we created a member parent class with standard member and student member as children. Both inherit common properties but implement different borrowing limits and fine rates. For polymorphism, we overrode the calculate fine method. Student members pay only 50 cents per overdue day, while standard members pay 1 ringgit. The system automatically selects the correct version at runtime. Finally, for aggregation/composition, our library aggregates independent member and book objects, while borrow record objects cannot exist without both a member and a book, showing a stronger compositional relationship.
Hi, this is Jinxi. Now I will go to the UML class diagram of our library management system. In our diagram, it shows course data structure and the relationship between all the classes. As you can see, the right side, the top is the library system class. This is our main entry of the system, and the library class is the central hub which aggregates all the classes like borrow record, member, librarian, and book. And this is the typical one-to-many management relationship. For the left side is the details of the library system class and library class. Next, I will go to the four business entities. All classes revolve around the borrow record class. It independently record the complete borrowing transactions, including borrow date, due date, overdue status. This ensures the data integrity and the historical traceability. Even if a member or a book is removed, it still can check the borrowing history before. In addition, the member class as a parent class is derived a standard member and student member. This make easy to extend a member type in the future. And the last is the book and librarian. They record the essential information in it. This is all for the UML class diagram. Thank you.
I will now demonstrate the functions of this library management system. Firstly, the system allows librarians to manage members. A member can be displayed in a formatted table, registered through entering the member type, name, and age, and the member will be added into the list of members. A member can also be removed by entering the member ID, and it will be removed from the list of members. Next, the system supports book management. The system can display all book details. New books can be added by entering the book title, author, publisher, publish date, and the date this book is added. And the book will be stored in the library's list of books. The book can also be removed by entering the book ID, and the book will be removed from the list of books. The core functionality of the system is borrowing and returning books. Book records are stored in an array list and can be displayed. A book can be borrowed by entering the book ID, borrower ID, borrow date, and due date, and a new book record will be added into the borrow record list. A book can also be returned by entering the book ID, borrower ID, and return date, and the book's return date will be updated in the borrow records list. Furthermore, the system supports overdue fine calculation and payment. The overdue record can be found by entering the borrower ID and book ID, and the librarian has to confirm the payment by entering the amount paid by the borrower. Finally, the system allows librarian management. A librarian can be displayed in a formatted table, registered through entering the librarian name, age, role, and hire date, and the librarian will be added into the list of librarians. A librarian can also be removed by entering the librarian ID, and it will be removed from the list of librarians.
I will now present the error handling for this library management system. So first, for example, if we attempt to put in something such as a string for the librarian ID, it will give us an invalid input showing the input validation. Then if we attempt to put in a librarian ID that doesn't exist, the input validation will also detect this. Next, for example, if we attempt to register a member and put in the wrong member type, it will tell us that it's an invalid number and ask us to put in a valid one. Next, another example is the input validation for when we attempt to add a book. For example, if we attempt to enter something in the published year that isn't a number, it will tell us that the input is invalid. The same thing goes for the month and the date as well. Next, if we attempt to delete a book that doesn't exist, for example, it will tell us that the book is not found. Or, based on the displayed books that we have, if we attempt to borrow a book that doesn't exist, it will also tell us that the book does not exist. Another error handling feature that this library system has is that it will not allow you to enter a borrow date that is earlier than the date that the book was added to the library system. Other than that, if we try to pay overdue fees on a book that is not overdue, then it will display an error message as well. After that, there's also error handling features for deletion of librarians. For example, if we enter a librarian ID that doesn't exist, it will tell us an error and that it doesn't exist. Another feature that this library management system has is that it does not allow members to borrow more books than they're allowed to. So for example, standard members can borrow up to 3 books, and now we will use example data to show this error handling in place. Now we can see here that if we attempt to borrow the 4th book using this example member, it will display that the member has exceeded the borrow limit, showing how this library management system handles the borrowing records.
In conclusion, our library management system successfully demonstrates practical object-oriented programming application. We have built a functional console application that handles all core library operation using clean 6-class architecture. The project highlights how proper object-oriented programming design creates software that's both functional today and scalable for tomorrow. By addressing fundamental questions about data protection, code reuse, flexible behavior, and object relationships, we have created a foundation that could easily accommodate new member types or library features. This experience reinforced that thoughtful architecture decision came before successful implementation. The system proves that good object-oriented programming principles lead to maintainable, collaborative, and future-ready software solutions.